Boys and girls, welcome back. Don't worry, I'm here. Day 2 of the Math Packet Review. I don't know how to tell you this, but I'm super excited to do day 2, just like I was day 1. So let's follow along. Let's try to get it done. Questions are a little bit harder, right? They're going to get a little harder as we go along. Question 6, if the radius of a circle is tripled, by what factor will the area increase by? What? Okay. You can't just automatically assume because it says tripled here, the answer is 3. Because clearly it's not 3, okay? So because I wouldn't have referenced that otherwise. So when you have problems like this, draw a picture and see if you can identify a couple things that will give you an answer. So I'm gonna draw a circle and I'm gonna make a little radius here. And let's just say I make that radius, I don't know, 2. Okay. Now, if the radius of the circle is tripled, meaning another circle with triple the amount of radius. So let's make another circle. These circles are pretty good, right? They're pretty circular, okay? So if I'm gonna triple that, it's gonna be 6. Now, we're talking about area. So I wanna know what the factor of the area will increase by. So let's find the area. Area of a circle is pi r squared. So I'm gonna leave pi by itself right now because if pi we're using in both problems, right, plural, I'm gonna just leave it, okay? So let's identify and let's try to solve things for the radius. So radius squared, so 2 squared is 4. So then the area of the smaller circle will be 4 pi. Yeah, you can multiply 3.14, but that's gonna make a messy decimal. There's no need for that. So 4 pi, okay. 6 squared is 36, okay. Pi, okay. So let's take a look at the areas now and compare them. So the small area circle is 4 pi, right? Or we can just classify it as 4 for right now, because pi, if they both have pi, we can just get rid of it. This one's 36. So how did I get from 4 to 36 with factors, meaning multiplication? I multiplied by 9, and that's going to be my final answer. Okay, now, why does it do it that way? Well, because if I'm tripling something, really and truly, I'm tripling something, squaring it, because that is how area of a circle works. Okay? So the answer will be C for number 6. Not bad. Let's move on. Oh, I don't think I have this in. No. Apologies. Number 7. I'm going to do that 4 more times. If 10 men can build a house in 90 days, how many men can build a home in 20 days? Ooh. Okay. Really quick, let's start to think about what this means here. 10 men can build one house in 90 days. Okay. So how many men can build a home in 20 days? So take a look at the days here. I want to know how one house can be built in significantly shorter time. So it better be at least kind of a lot more people. Now here is what we're looking for. How many total days does it take to build that one house in the first scenario? 10 men are spending 90 days total, but man hours or man days is 10 times 90, which is 900. So it will take a total of 900 days if you add up every man's days together to build that one house. So I'm now going to divide that total amount, because that's my rate now. That's how long it takes to build one house with 10 men. I'm going to divide that by 20 days, because that will provide me with my answer of how many men it's going to take to make that work. 900 divided by 20 is 45. And that is how many men it's going to take to build one house in 20 days. And again, it makes sense. 10 men for 90 days, right? 45 men for 20 days. Need a lot more men to build a house in a lot shorter time. Okay? Moving on. So your answer is C again. I promise I'm coming back. Don't pause me. Number 8. If A over B equals 5 over 6, then what is 56A over 20B? What? So there's a couple ways we can do this. I'm telling you what A is, it's 5. And I'm telling you what B is, it's 6. You can substitute it and then solve, because you're going to multiply and then simplify, because these are really small. But why don't we just try to simplify 56 over 20 first to make the numbers a little bit easier? So 56 over 20, we want to simplify it. Well, what's the greatest common factor of these two numbers? What can I take out of these numbers? And that answer is 4. So I'm going to simplify the fraction by dividing by 4 on top and bottom. And that will give me 14 over 5. Now, that's a way easier number because it's way smaller. let's substitute the 5 and the 6. Right, so 5 and 6. Now I can cancel these two out, right? Because 5 divided by 5 is 1. So then I get the fraction 14 over 6, not 16 over 6, because that's silly. Not here. So we have to simplify further, and I get 7/3, which is D. Now the other way you could do it was, again, multiply 56 times 5, multiply 20 times 6, and then simplify that way. I just think that my way is a little bit easier. Okay. Next one. Number 9, if the length and width of a rectangle are tripled, oh, there we go again. Another one of these problems. The area of that rectangle, go away circle. The area of the rectangle will increase by what percentage? Okay, so this is kind of like the first problem we talked about, but it's different because I'm looking for increasing percentage. So again, let's draw a couple of rectangles. Okay. If the length and width are tripled, so let's say the original length and width, and I know this does not look to scale, but let's just make it easy numbers. So the first rectangle has a length of 2 and a width of 1. We're tripling it for the next rectangle. So 2 times 3 is 6, and 1 times 3 is 3. So let's take a look at the area now. Area is length times width. So 2 times 1 is 2, and 6 times 3 is 18. Okay, now, how did I go from 2 to 18? By factors. I multiplied by 9. Now, the increase percentage is going to be D, 900%. And here's why. Both 9 and 90 of the difference here means I'm not going to get to double of 2. I have to do 100% times 2 to get to 4, because that would be the entire thing, 100%, all of it, and then doubling it would be 4. If I do 9%, this number is going to go up by a very small amount. If I do 90%, this number is going to go up by almost 2 full points to 4, but just a little less. It'll be like 3.8 or something. So I have to have a number in the hundreds if I'm going to make a big jump from 2 all the way to 18. Okay? So it has to be 900%. And you can figure that out too by dividing these two numbers, but we're not going to get into that too much because we want to save some time. I think I'm over the 10-minute mark. I'm going to say it's 10 minutes and 40 seconds. Oh, wow. 7 minutes and 22 seconds. What is happening right now? You did some time travel maneuver on me. Rachel donated $3,200 to her favorite charity last year. Rachel gets paid $5,400 each month. What percentage of her annual salary did Rachel donate last year? Okay, so she gets paid bank. She makes $5,400 in a month. So we want to multiply that by 12 months to see how much she makes in a year. And that figure is $64,800. Not bad, okay? Now that's how much she makes all year long. We want to know the percentage of her annual salary. Annual means 1 year, okay? So she donated $3,200 of that money. Okay? Certainly really small in comparison to her annual salary. So it better be a small number. And all these are pretty small. That's a little bit too big. But all these are pretty small, so I'm probably guessing it's going to be one of those three. So what we're going to do here is we're going to divide. So 3,200 divided by 64,800, and that value is going to give me, ooh, I didn't have that down. Oh yeah, it's B, 4.9%. So it'll give me like 0.049. Move the decimal place to the left. I'm sorry, to the right, so we can get the percentage, okay? So again, small value compared to her annual salary. Guys, hope that you enjoyed day 2. Day 3 and day 4 are coming up. Just 9 minutes, booyah!